Hello and welcome to Alchemist.camp, where we become better Elixir programmers by building things. Today's challenge is to flatten a list. By flatten a list, I mean take a list that's deeply nested. Then after you flatten it, it should look like something like this. So you just get rid of all those extra layers of enclosing lists. You just have one list and all the elements in it flat. So there are two ways we're going to solve this today. The first way is probably the more beautiful way, and then the second way is a bit more performant. And before we get into it, let's look at what's involved in flattening a list. One of the confusing things for a lot of Elixir programmers is the way list syntax works. So if you saw a list of 1 and 2, that's actually the same thing as if you had a head of 1 and a tail of a list that just contained 2. Because actually you've got one cell 1 that points to another cell that holds 2, and that second cell doesn't point anywhere. And if you had a list with a third element in it, it would look like this. IEX.bat for those of you on PowerShell. One of my least favorite things about PowerShell is that IEX means something. All right, we'll just paste that in, and you see that's the same as 1, 2, 3. You can also take a look at how things work by breaking it into head and tail. So this is a good way to play around and discover things. We'll just call it H and T for short, equals 1, 2, 3. So this is what lists look like under the hood. Now I think it's very useful to look at an empty list within an empty list. So that's actually a head of an empty list and a tail of an empty list. And if we had it nested one level deeper, then it's like that. So the tail is still just an empty list. And if we had a single element inside a list, the head is the element itself, and the tail is an empty list. So notice that the end of a list is always an empty list. Okay, with that out of the way, let's go back to the problem. So there are three scenarios we want to consider when we're dealing with a list. The first scenario is if we have an empty list. So to flatten an empty list, it's pretty straightforward. Another scenario is maybe the list we're flattening is some kind of list. Then another scenario is maybe it's just one element. So these are the things we're keeping in mind. Is it an empty list? Is it a fairly normal looking list? Or is it a single element? So let's get to it. The first solution, I'm just going to call Squish. It squishes the list down. I'm not calling it flatten because we've got more than one solution. So we've got to consider what to do with an empty list. Well, that's actually pretty easy. If you've got an empty list, then the flattened empty list is just an empty list. Now if we have a list with a head and a tail, which means it's like a real list, it's not just a single element, then we're going to call itself. We're going to squish the head and append that to the squished tail. Let's look at the append syntax really quickly. So say we have our list. If we append 5 to it, it looks kind of funky. So one way you might think of dealing with this would be take your list, append 5, and then append an empty list. And that doesn't work because you can't append an empty list to a 5. You could do this. Or the easy way would be you just do this, because this is equal to 5 and an empty list. The head of it is 5, the tail of it is an empty list. Okay, so the reason for this quick detour is the tail must be a list, or the squish of the tail must be a list, or else this won't work. So if we have a single element, when we squish it, we really need to return a list. So we'll do this. This looks really simple, and in a way it's simple, but let's go through the logic here. So if we passed in an empty list, we get an empty list. Say we pass in just a list that contains a single element. Say we pass in that 5. Okay, so we have a head and a tail. The head is the number 5, the tail is an empty list. So we append a squished number 5 to a squished empty list. A squished empty list is still an empty list. Squished 5 is a 5 inside an empty list. And we're done. If we had the list of 1, 2, not all of this, but just the 1 and the 2, then the head would be a 1, and the tail would be the list that just contains 2. So we would return 1, and then append to it the squish of the list that just contains 2. The squish of the list that just contains 2 works kind of like the 5 did. The head is just the number 2, and the tail is an empty list. And the squish of the empty list is still an empty list. The squish of the number 2 is the list with the number 2, so it will return a list of 2. You append a list of 1 and a list of 2, then you get the list of 1, 2. So nothing changes. If we had an empty list inside of an empty list, then we would have we'd end up doing an append operation on 2 empty lists, which returns an empty list. So let's actually save this and pull it in. And we'll also copy this. ch14.ex. List is unused, that's fine. Actually, let's import it also. So if we squish list, we get that. Okay, now let's make our list more complicated. We'll use that one. If we squish this list, now we get 1, 2, 3, 4, 5, 6 as we wanted. So you can see this actually does work, and it's extremely elegant. The problem with this is the append operation is very expensive. And that's because lists are linked lists. So to go to the 50th element of a list, you actually have to traverse element number 1 to find 2, which points at 3, and then 4, and so on. You have to go through 50 elements. It's not like an array where you can just look at the offset and move to the memory address that's 50 times however big the items are further in memory from where you started. You actually have to go one by one by one because they're not in memory contiguously. So what's fast to do with a list is add an item to the front of it, because all you have to do that is have a new item point to the first item, and that new item just became the first item and everything else was shifted down one. So what we're going to do is make a different version of flatten that reverses a list first and then puts each item onto the front of it, actually puts it into an accumulator. So we build it up in kind of in 2 steps. So we'll call this version Squash. And if we just get one element, then we will call it self and give it an empty accumulator. So this accumulator, this empty list, is going to be where the solution is built up. So every time it calls itself, it's going to call itself with a list. and it will process the list item by item and move those into an accumulator, as it calls itself, successively. And it's going to be backwards, so we need to call enum.reverse when we're done. The simplest scenario is if we have an empty list. And in this case, we just return the accumulator, because we've already processed the whole list and it's time to return the result. A slightly more complicated situation is if we have a list, but the head of the list is just an empty list. So it's got a head and it's got a tail. The head is an empty list, and then the tail is whatever it is. And if that's the case, then we're just going to squash the tail and throw away the head. And we'll pass the accumulator on without adding anything to it. The next scenario is a little bit more complicated. That's when we have a list and the head of the list is also a list. And there's an accumulator still. And we'll use when is list head to restrict this to when there's a head. We'll come back to this one in a minute. I think it'll make more sense if we do the next one first. Now we've got a situation where we know the head of the list is not a list, and that's because if it were, the function definition on line 10 would match. So the head must be a single element. And if that's the case, we're going to recursively call our flatten again, and we're going to pass in the tail to the function as a list. That means we're passing in all except the first element. And then we're putting that first element onto the beginning of the accumulator. So let's say that we had a, actually, you know what, I'm gonna move this down to the next line just since I've got the font so big. So let's go through this step by step. Let's say we called the function with a list of 5, 6, and 7, and an accumulator that just had the number 1. So this will call itself, and it will pass in just the tail. Well, the head of 5, 6, and 7 is just the number 5. The tail is a list of 6 and 7. So the tail is just going to be 6 and 7, and the head is 5. So we have 5, and then the accumulator. And we know that this is the exact same thing as just the list of 5 and 1. So we're processing the list item by item. It's very straightforward. If the head had been an empty list, it would have gotten thrown away. Now let's look at the more complicated situation here, where the head is a list itself instead of just an empty item. Then what we do is we squash the tail. So we pass the tail into the list just like we do here. But into the accumulator, we pass the squashed version of the head and the accumulator. So in this case, maybe our list was, say, a list of 5 and 6 and then 7. Say we had that. Well, now the head is 5, 6, and the tail is just the list of 7. So we're going to squash the tail of 7, and then the accumulator gets the squash of the head, and the head is 5, 6, and 1. Now in this case, the head of this list is just the number 5, so it's going to work the way we just went through, and 5 will get moved into this list, and then 6 will get moved into this list the next time through. So we'll end up like ultimately the squashed down version of this is going to be 6, 5, 1. And then the next time through, the head will be the number 7, the tail will be an empty list. So the number 7 will get passed into the accumulator, and then the next time through, it will be an empty list, and this will get returned, and it'll get reversed, and then that's it. So this is a little bit more complicated, but it avoids that expensive append operation. Get rid of this, and let's just add some testing facilities here. In order to test the performance, I guess, okay, actually, let me say, we'll just test that this thing works at all. It's entirely possible I made a mistake. Okay, and squish the list works. Now can we squash the list? Yes, we can. Okay, now let's add some example material. Let's see, we'll start with an import, just in case we want to run this from outside of IEX. And we're going to make a gigantic list. So list.duplicate. So this is going to be a list of 50 items that are each foo. And then we're going to pipe that into another list.duplicate. So now we're going to have a list of 50 lists that each have 50 items named foo in them. And now it's 3 levels, and now it's 4. This is enough stuff that even today's fast computers will take a little bit of time on it. Then we'll use the Erlang timer to capture the time it takes for each of these functions to flatten this huge list. And that's timer.tc, and it takes a function, and then we do stuff. So we'll squish the list, and then we'll do the exact same thing again, except using squash, and we'll save that one to variable t2, and then io.puts. Squish took time 1, and then we'll copy this down for squash. And took t2, not time 2. And finally, I know squash is going to be faster, so we'll say squash was t1 over t2 times faster. All right. So Squish took almost 2 million units of time. This must be microseconds. And Squash took 640,000. Squash was 2.92 times faster. So there you have it. We have a beautiful way to flatten lists, and we have a more performant way to flatten lists. Thank you for joining us at Alchemist Camp. Till next time, code on.